For today's video, we're going to briefly go over solving the x and y intercepts to a two-variable linear equation. And so, to start off, let's talk about finding the x-intercept. Now, when we're finding the x-intercept, you can think about this also graphically. If I have my coordinate plane here, and I have a red linear function like this. My x-intercept is located here along the x-axis. And then conversely, my y-intercept in pink will be located here. Okay, so to solve for the x-intercept, which is in orange, we need to set y to be 0. So I'm going to go ahead and write that down. So to solve for the x-intercept, we need y is equal to 0. Okay? And so that's exactly what we're going to do. Suppose I have a basic problem, and I'm going to have, let's do 12x plus 10y is now equal to 5. And I want to solve for the x-intercept. So what I'm going to do is I'm going to set y equal to 0. So I'm going to let y equal 0. And so then that means I'm going to plug this into my equation, and we're going to find out what x is. I'm going to get 12x plus 10 times 0 now that I've plugged in y is equal to 0, and that's now equal to 5. 10 times 0 is clearly 0, so I just get 12x is now equal to 5. And then dividing both sides by 12, I get that x is now equal to 5 divided by 12. Okay. Now, on the same side, in order to find our y-intercept, we do something very similar. Okay, except we're going to replace x this time. So to find the y-intercept, let x equal 0. Okay? So let's take our same equation and do the same thing there. So I'm going to have 12x plus 10y is now equal to 5. I'm going to let x equal 0. And so then that means I'm going to get 12 times 0 plus 10y is now equal to 5. 12 times 0 is 0, so I just get 10y is now equal to 5. And then I'm going to divide both sides by 10. And so I would be left with y is now equal to 5/10, but we all know 5/10 can be simplified to 1/2. And there's the answer. So we have our x-intercept of 5/12, and then our y-intercept of 1/2. And that's in the case of any linear equation. Now in this case, we started with the standard form of a linear equation, where we have ax plus by is equal to some number c. But suppose instead we have slope-intercept form, which is something you may more commonly see. So if we have slope-intercept form, let's say we have a problem that looks like this. Y is now equal to 4x plus 7. Now this problem, it's actually very easy to see what the x and the y intercepts will be. If I let x equal 0, okay, then that means this entire portion here, the 4x, goes away. And so that clearly just means that y is now equal to 7, which means my y-intercept, okay, is 0, 7. Okay. Now, if I do the opposite side, and I'll want to find my x-intercept, so I'm just going to rewrite the problem I had, which was y is now equal to 4x plus 7. If I let my y equal 0, okay, then that means I'm going to be left with this problem. 0 is equal to 4x plus 7. And then to think about it in simple terms, we're just going to subtract the 7 over. And it's really just the inverse of whatever this number is here on the right, is now what we have on the left side of the equation. And so I'm left with negative 7 is now equal to 4x. I'm going to divide by 4 like we always do. And then that means x is now equal to negative 7 over 4. And you can simplify that if you want to, but I'll leave it as just negative 7/4. And so that means my x-intercept is equal to negative 7 over 4, 0. Okay. That's basically solving x and y intercepts for linear equations in 2 variables. It's something very common that we do. It's very useful. It helps us graph a problem, because from here on you can go on and actually graph this equation. So suppose I'm working with my second problem here, and so I just need to remember what my y-intercept was. My y-intercept is 0, 7, and then my x-intercept is negative 7/4, 0. That means in a very general graph, I would have something 1, 2, 3, 4, 5, 6, 7, and yeah, I was figuring I was going to do that. Go ahead and do this part again. 1, 2. Okay, here's negative 1, here's negative 2, here's 7. I would basically be left with a line that looks very similar to this. Something that looks like that, where this is negative 7 over 4, 0, and this over here is 0, 7. It makes visualizing your graph very easy. Makes visualizing your line very easy, when you know the x and y intercepts. And then from there, if you wanted to, you can even extend it to figure out what the slope of the line is.